just seeing how many commons are there in the morning. Yeah, go ahead, please.
Good afternoon, everyone. Myself, Komal Mehta. Today I am going to present my pre-submission seminar on performance improvement of VANET with nature-inspired biological computing. I have done my PhD under the supervision of PSOZBR and Malik ma'am. These are my registration details. I have delivered 10 progress seminars and published 8 papers. According to this, I have organized my presentation. Introduction. I am motivated to go for this research work because as we all know, the vehicular traffic is increasing day by day, which is increasing the probability of accidents also. So to reduce this, all over in all over world, some conditions are doing. So to fulfill those, we are using vehicular ad hoc network to save the lives also. So you can see over here that I draw this graph from the WHO report that the developing countries have more death due to road accidents compared to the developed countries. Just because in the developing countries the scenario to control the traffic is less, and also the vehicles which they use are mostly the two-wheelers, and that's why the death rate are more in developing countries compared to the developed countries.
India is developing or developing?
Yes, sir.
India is a developed country or developing
Sir,
country?
it's a developing country. Right?
Still?
It's still a developing country.
Yesterday we sent 104 satellites.
Yeah.
Yeah, it's a developed. The context is important. Developed. Okay.
For transportation, we are developed or developing?
Sir, ma'am, in actually transportation reason, we are maintaining the laws and we are designing the smart cities also, but it's in still the perspective point.
Developing or developed?
Ma'am, we can say it's developing, not developed. Exactly.
Correct.
Yeah, this is the road accident scenarios of India. We can see that the accidents are increasing, and mainly the death rate is increased 4.6% compared to 2014 and 2015. So we have to reduce this death rate. Accidents, this is the scenario where worldwide scenario in which they have designed the 4 pillars. They divided all this in 4 pillars: road traffic management, safer road and mobility, safer vehicles, safer road users, and post crash. If any accident occurs, then how will they manage the post crash? This is the road safety step taken in the India. Here you can also see that accidents we reduce, number of accidents we reduce, but the person killing is again more in India. This is intelligent transportation system, the basic model.
You have a data of
basic
China?
model.
China, you have data?
Of China? Sir, exactly I am not having the data of the China. This is the basic model of intelligent transportation, the technologies which are using to control the data, to provide the wireless communication, to provide optimization, and these are the applications in which basically we use vehicular ad hoc network to provide the communication. These are the features and challenges. If we see the challenges, these are basically due to the high mobility and non-centralized system. So these challenges occur mainly of these 2 reasons. And the performance parameter divided according to the area in which we are going to improve the performance, and I have selected the routing protocol. So I have selected 5 parameters according to the routing protocol to evaluate the performance. The road topologies in which I have selected the cluster based road topology according to the literature survey, as I found that cluster topology is more appropriate for vehicular ad hoc network. And the nature-inspired biology computer, the features of nature-inspired biology computing basically supports the reduces the challenges of the VANET. That's why the NIVC, I propose that NIVC improves the performance of VANET. After that, these are the objectives of my the work I carried out. you can see the performance. I evaluated these performance, 5 performance parameters. The simulation carried out for different data rates and for different speed. NIBC and fuzzy PSO, fuzzy NIBC also I have designed. The literature review, I have taken the literature review broadly in 3 areas. First, to support that what the previous work done in the routing, based on the routing, that what the previous work done in according to routing, and it will support that if some parameter is improving, then the other parameter is decreasing at the cost of other parameter. Here also you can see the packet delivery ratio and short average path is increased, but at the cost of control overhead.
Which year they are published?
Sir, these are published. I have done basically the literature survey from 2008 to 2015. So this paper is of 2009 and this paper is of 2010. You can see. These are also the according to the routing, and we also see here also that packet delivery ratio is increasing, delay and overhead is controlled, but again the packet drop is increased. After that, I did the literature survey based on the NIBC technique. NIBC technique used in vehicular ad hoc network, and what we found that NIBC is supporting basically the is a good technique to control the challenges of vehicular ad hoc network. Here the Salim Bikman designed artificial bee colony optimization technique, used the artificial bee colony optimization technique, and shows that they outperformed over AODV and DSDV algorithms. Then the Malthus sir indicated that OLSR, they actually he used the NIBC technique to find out the optimal parameters for OLSR, and show that traditional OLSR is that NIBC used optimized technique is good over the traditional OLSR. Then the routing based, I did the literature survey based on the routing topology, that which routing topology is better for the vehicular ad hoc network, and these papers will they go through the deep intense study of these routing topologies and shows that the cluster based routing topology is more appropriate for vehicular ad hoc network. Just because it is the mobility of the vehicle is very high and the topology changes very fast, so to divide the network into small zones is more convenient to find out the stability basically. These literature survey is done according to the fuzzy logic. If we use fuzzy logic, what happened in VANET? So these Samuel Y. Liao has find out the link status based according to the fuzzy logic. Now the adopted methodology, first I have selected a routing approach, that is zone based routing. Then I have selected 5 performance parameters for routing. Then set the simulation parameter, I have selected NS 2.34 as a simulator. After that I created the zone, then the selection of zone header. The selection of zone header depends on the fitness function. After that, if any source want to send the data, it will send the route request packet. The route selection is done by designed fixed algorithms. Then the data transmission occurs through the found route, and after simulation, these 5 parameters get evaluated through the trace file. This is the flowchart of creation of zone. Initially, I divided the area into static zone, that of 500 meter across 500 meter. The node had the table, send hello message to maintain a routing table, and it makes a 2-hop table. Means the neighbor to neighbor information also available to the node. Then we find out the center of the each zone, that is CH1. After that, I find out the fitness to select the cluster header, and this fitness depends on the relative velocity among the neighbor nodes, the energy and the distance of that node with the center of that node. Initially, all the node behaves as a cluster header, but after they will update its position according to the fitness function.
Why 2 hops? Why you can't do in single hop? What is the overhead for 2?
Actually, sir, as I will go for AODV, you will see if any neighbor have the destination in its 2-hop vicinity, then there is no need to send the data to the cluster head and increase the overhead. So I have selected the 2-hop neighbor.
Now, single hop is which
Single
one is
hop.
more in terms
Sir, actually single hop is, you can say it reduces the cluster head, but it increases it reduces the overhead, but it increases the delay also. So I want to reduce the parameters, that's why I selected 2-hop.
Okay.
Then the AODV, as you can see, creation of zone is common for all the 6 algorithms. After creation of zone, if the source node find that if destination not in its 2-hop distance, then only it will send the request to the cluster header. Otherwise, it will directly send the data to the destination. And then the cluster head is selected. After sending the request packet to cluster head, the cluster head searches that node exists in its own vicinity. If not, then it will send data to the again cluster head. And through that we have find out the root. Here we am showing that node 39 want to send to root to node 30. Want to send data to node 30, and this root is founded through AODV. This is showing that the AODV has which neighbors and how it will send, to whom node it will send the request to the neighbor nodes. These are the performance evaluation of AODV routing protocol. When I am changing the transmission rate from 100 kbps to 500 kbps at the difference of 100 kbps, here the speed is constant at 5 megameter per second. Again, I have did the simulation for these 5 combination. Here the speed is changing from 5 meter per second to 25 meter per second, and the data rate is constant at 100 kbps. Now, PSOZBR VANET is basically using the artificial B algorithm. After finding when the source node sends a road request packet, we initialize some parameter. P is indicating the search space, N is the total number of nodes, and phi is a random number which is having its values between 0 to 1. Initially, I am taking the value of phi is equals to 1. It changes if any node is stuck in its local best position. If any node is stuck in local best, then the phi randomly changes to move out that node from the local best position. According to this, here the phi is equals to 1 initially, and we modify the distance. We can say first we just evaluated the distance among the source and the destination node and the neighbor node. Only that neighbor node is selected which is in the direction of destination node. If node is not in the direction of destination node, we will not select that node and eliminate that node. So through this path, the source will send the data packet to destination. These are the performance parameter evaluation through PSOZBR VANET. And we can see in result section that it is improving the performance.
How do you see the improvement?
I have made the table and find out the percentage improvement. In the result section I will show you. These according to first we have changed the transmission rate and then I have changed the speed. This is the BFO. When I am using the BFO, it is again some parameters again initialized in here. P is for search space, N is for total number of nodes, MC is the steps. Means chemotactic steps. How many chemotactic steps it will take? Again, C it depends on the tumbling steps. How much tumbling steps it will take? Here we are using 3 tumbling steps. Reproduction is not using over here because we are not deleting any node. We are only doing the sorting here. So R is equals to 0 and E is equals to how much steps we will take after tumbling. Elimination for elimination means here we will see the first I am calculating the cost of the each node according to the mobility factor and the signal strength factor. These are those equations which I am using to calculate the mobility factor and signal strength factor. The mobility factor depends on the distance of two nodes, two neighbor nodes, and the signal strength factor is find out the threshold node and this transmitted power. This threshold power is received from the IOP file from the NS2. Here the bacteria will swim CI step and it only do the tumbling if it is stuck in the local node, and also it will how will we check that it is stuck in the local best? In 3 steps it is not dispersing its any neighborhood, it means it is in the local best position. So from getting out from that local best position we do the tumbling, and what is doing in the tumbling, we multiply with this factor with the random factor 5. These are the parameters evaluation when I have changed the transmission rate and speed. After that PSO, again PSO we initialize some parameter. R1 and R2 are the random variables, P best and G best are the local best and global best. Omega is the value which we can change if we are going to modify PSO. Here I am not modifying the PSO. Initially R1 and R2 is 0.5, and it will change randomly to get out again from the local ghost position. Here we can showing this that 0, 1, minus 50 will not selected because the which we want in the direction, if the x is the minus and y is in the positive direction, then the node gets selected, otherwise it will not get selected.
What is the physical meaning of minus?
Minus is basically the distance. Physical meaning the position of the destination node and the position of the source node.
Yeah, it can be positive. No? Minus means what?
Minus means the source minus destination. I am finding out x.
Position is given by xy.
Position
0
is,
minus
yes.
50.
Yeah.
No, not that. You look at that.
Yes.
What is the physical
Means
significance?
it is in inline position. Means y in the vertical position these nodes are inline.
If it is 50, 100?
Yes, sir.
Next one.
Next one,
50,
it is in y position 100 ahead from the
So one
x
is
is
ahead, one is lying.
yes, one is lying. Actually, I am taking the scenario in which it is a two-way scenario. Some vehicles are moving in the left to right, and some vehicles are moving in the right to left. So two-way scenario is this. So source and destination are in the opposite side, and this one. This is the route found through PSO. It will find this route which is in the direction of the destination node only. We can see over here, initially the node itself is global best and local best, then it modifies its value according to the change in the velocity. The velocity and the position changes. If the velocity and position value is less than the other value, then it will become the local best, and if it is high, then it is.
What is NS?
This is not selected. If it is not in the direction of, then we will not select and not evaluate the value of velocity, and so it will reduce the number of iterations. Here these are the performance parameters. After that, I designed two routing algorithms. These are hybrid routing algorithms where I have calculated the link status between each node and using according to these three factors. First is bandwidth factor. It depends on the channel ideal ratio. And again the mobility factor. It will depend on the nodes that it is in the vicinity of the neighbor node or not, and link quality factor is dependent on the hello reception ratio. Then these are the rule tables and fuzzy cost evaluated in declassification using center of gravity method. After finding out the link status, the parameters have initialized according to previously defined BFO method, and it will again by this CI indicate the tumbling step, and it will tumble if it is stuck in the local best position. The value of it is 3. If any node not dispersing the node in neighbor 3 nodes, then it means it is in a local best position, and from carry down from that we multiply it with a random number. and this is basically the membership function of the output to find out the link status.
X-axis.
On this x-axis, so this is the value which the fuzzy value which we find out on the through the link status value. Whose minimum and maximum value which we find out. So these we have used a min and max function. We are using here three values. So among them, here bandwidth factor, mobility factor, and
Your
this.
member function is there in the y-axis.
Yes, member function is there. This is the basic. We are finding out the fixed value here. So these are the value of the rules which I am getting. This unpreferable is what, acceptable is what, unpreferable. This is the value of the degree of the LS. This axis is showing the degree of LS using minimum method. The rule founded through fuzzy BFO, and here we can see that we disperse these nodes because the fuzzy cost is 0 and this node is selected because here the fuzzy cost is high. These are again the parameters. Then the fuzzy logic which I explained earlier, which we used also in PSO. The link status calculated by that fuzzy logic. After that we initialize some parameters of PSO and finding out the root. What is good in this approach, that the link status is we are calculating the cost of each and every link using fuzzy logic. If the link status is good, then we only select that time we are selecting that node which are in the direction of the destination. These are the performance parameters. Now the results. Here I have shown the comparison table in terms of packet delivery ratio, and we can see these all are in the in compared to AODV. The improvement in compared to AODV, and we can see over here the packet delivery ratio is high in BFOZBR. If we evaluate QSB only for this and this percent, it is less, otherwise it is high. If we study the PSOZBR, again it is showing the improvement. The fuzzy logic is again showing the improvement. So we can conclude that if we are using NIVC techniques, the packet delivery ratio shows the improvement over AODV.
But minus 10%, 11% means what?
So it means the packet delivery ratio of FPSOZBR is less in these cases.
Zero?
Yes, sir?
Minus percentage, minus means...
Minus means that, sir, I have divided this, the FPSOZBR packet delivery ratio from AODV and divided by this.
In terms of percentage, I don't get the minus 600.
Sir, minus is saying that for these cases the improvement is not happened. For PSOZBR is not improved for these cases if we are using the transmission rate over
Transmission rate, it is this
yes. The PSOZBR is not applicable for this. Here we can use FPSOZBR. It is showing the improvement in terms of packet delivery ratio.
What's I want to say?
But,
Probably we can say dash. We can write that this technique is
rather
not
than
working.
Yes.
So, but we should not write.
Yeah, you write 64, 76, and 88. The rest is to put dash.
Yes.
Okay.
Or we can mark, asterisk.
Okay.
That there is no significant improvement.
Yeah, something
But
like that.
minus should not be there. So that you can.
Yeah, sure, ma'am.
But your PSOZBR
Yes, sir.
is not great, no?
PSOZBR. Yes, sir.
Yeah, middle one. Things are not that great, right? But if you look at them,
Yes, sir.
achievement is not that good.
Yes, sir. But actually what happens, we are evaluating here 5 parameters. So these are already interrelated to
This
each
is only
other.
packet delivery.
Yeah, it is only for packet delivery ratio. It shows sometimes improvement in any other packet and for any other
But
parameter.
if your table will all out of 5,
Yes,
the
sir.
best. You have some table?
From all of 5, yes sir, from all of 5, yes, I can show that fuzzy BFOZBR is performing better in compared to all other algorithms.
You have that table?
No sir, I have not read table, but I can show
It
that.
will be nice because you
Yes,
started with You said that 5 parameters that
Yes,
you want
yes,
to take,
sir.
and then you have different algorithm.
Yes, sir.
And then show a table where, if not all the 5, in
Yes,
a
sir.
given scenario,
Yes, sir.
this is the, you can conclude
Okay,
saying
sir.
that this is the one which at least gives at least 3 to 4 parameter, this was scores.
Okay. Yes, sir. So from the packet delivery ratio, we can see BFOZBR and FBFOZBR is improving the performance.
These are all with respect to what?
AODV. Yes, sir. Then the packet delivery ratio, again this negative sign is indicating the packet delivery ratio is less in these algorithms compared to AODV.
You should get rid of these things.
Fine.
Okay.
So here we can also see
Where
that
we came in terms of back and drop ratio, which is better?
BFO and FBFO. FOBFO is improved over BFO.
Where? I don't see.
So you can see here minus 17.7 and
Among the
from
minus we
here-
are comparing. What I am saying is, among the minus,
Okay, what is the formula you have applied? Can you
Yeah.
explain to sir?
Ma'am, I have applied that the packet drop ratio of this is minus AODV and divided by AODV.
no, this doesn't mean anything. Meaningful.
What? Yes.
You can avoid all those.
Yeah, I
Take
just-
only, instead of 5, take 4 parameter.
I asked her because her
No, it's
base
okay.
was AODV, so I asked her to compare with all the methods what she had done for all
Correct, fair
parameters.
enough.
But then if it is not working, so we
Yeah,
can leave it
if
that.
it is not in our favor, then we
We
can
can
just
leave it.
hide this.
Yeah, yeah, that is not.
We are
giving
known
it-
for return files in
I-
computer science.
Yes.
This portion.
Okay. So in packet drop ratio again we can see
So there is no
Next, third part.
improvement for packet drop for by any of the method. That's
That's
an
right.
inclusion.
That's the reason.
That's it.
the packet drop ratio is improvement is BFO as ZBR and FPFO ZBR is showing the improvement
That
basically.
formula is somewhere wrong.
Yes.
It is
Somewhere,
so-called
I mean,
negative.
yeah.
So we will
Yeah, you will relook
see
at
that.
it.
We have to
See, when you say AODV,
Yes.
with respect to that,
Yeah.
these methods are better than that,
Yes, sir.
should lead to some.
Actually, sir, I have.
This is your ratio. What is the parameter AODV 0.644?
Yes, ma'am.
Okay,
First one.
Yes, yes, ma'am.
0.644
Yes, yes.
minus how you are calculating the improvement parameter.
Ma'am, how I am calculating the improvement parameter.
So 0.369 is better or 0.644 is
Ma'am,
better?
0.369 is better because it's a packet
But it
drop
doesn't
ratio. The
reflect.
packet drop ratio should be
But
less.
that is not
Reflecting
That is what I wanted to say.
the way you are presenting, it doesn't reflect.
Okay.
If you say that particular 0.6, 0.6, 0.5, 0.6, 0.3,
Yes, sir.
0.1,
Yes, sir.
then there is an improvement. FPSOZBR. But if I look at this doesn't say that.
Okay,
Okay.
go back to the previous slide. If this is the case.
Same.
Okay. So now,
So-
which is the method which AODV is 0.378.
Yes, sir, ma'am.
So now, which method is better?
Ma'am,
You
FBFOZ.
said FBFO,
Yes, ma'am.
but FBFO has a higher range than AODV. Look
Ma'am,
at
actually what I interpreted that packet delivery ratio should be high. So the percentage improvement should be positive, and if packet drop ratio it is low, the percentage improvement should be negative, which I interpreted. And
so that is correct. But then that we
Percentage,
will
yeah.
change the present.
Yes, ma'am, I will change, surely.
No, this part, this the second part of it, you just present in a
Yes,
way
ma'am.
it will get
Still,
reflected.
it's because packet delivery ratio should be high. So there it is positive and FBFO is this
That's
calculation
okay.
seems to be
Yes,
good.
yes.
But next one
then
we
I
have to change. Yes.
Actually I will
So it's a
change.
matter of presentation.
Yes, yes,
So
okay.
For third parameter.
next
Third parameter is again control overhead, and
Yeah,
it should
same
be
thing,
less.
same
So
thing.
that's why I indicated the empowerment
It
in
should
terms
be
of
low.
it. Yes,
Okay.
yes, ma'am. Then from this also we can see that the FBFO ZBR in FPSO ZBR here is improving the
You show
overhead.
us from the reading only.
Yes,
Don't go for,
okay, okay.
right side.
Here you can see.
that itself will tell. They should be low, they should be high. By
That.
that itself will explain
Yes.
rather than this part.
We'll do that.
Some.
So here also we can conclude that fuzzy BFOZBR is more appropriable in terms of control overhead, and fuzzy PSOZBR is also showing the improvement in terms of
You have to project, Komal, at the
Yes,
same
ma'am.
time, like
Yes, sure.
variation of speed. So whatever is speed, still this method works, and whatever is your transmission rate, still it
Okay.
works. So there,
So for 100 transmission rate and for 10 meter per second, we can see the AODV is 37098 and QoS is less. Again, but BFOZBR have showing the more control overhead compared to AODV. In this, control overhead is less. Here also the control overhead is less, and there also a control. Means for this particular combination, all the NIBC techniques
Try
are.
to define your improvement using whatever the formula.
Yes,
Without negative, if you get something with
Yes,
result.
sir.
Otherwise, that itself will be self-explanatory.
Okay, sir.
You say or define this, and then the next.
Okay, sir. I know.
Next.
Then the average delay
Next. Yeah, you can say.
and throughput. Throughput should be high, so the percentage is coming in positive here, and we can conclude it that the SBFO-ZBR is showing improvement in all the 5 parameters. So conclusion, the vehicles are divided into 6 size zones, and we can modify the number of the zones at runtime by calculating its relative velocity and the position. The transmission rate is indicating, if we vary the transmission rate, it is indicating that performance improvement increase in 2 cases, and for varying speed, it is showing that SBFO-ZBR is good compared to AODV. These are the publications and these are the references.
See, your literature, GHRC, no, you are not given any reference of your own. You know, there are a lot of work done by your own group. In the literature, I didn't see. Why? Intentional or not?
No, sir, actually, it's not intentional, but I should mention it.
Yeah.
Yes, sir.
In your group, what is done, you know,
Yes,
that
yes.
also should be there.
Yes, sir.
You know, an extension, you know, that is
Yes,
good.
yes, sir.
The second one, as I said, all the data presentation,
Yes, sir.
it should be clear looked.
Yes, sir. I will change.
What do you suggest for future?
For future, sir, actually, right now I have designed the network by my own and implemented all these and related all these parameters on that. In future, I want to do this on the real environment.
That is one.
For
The
this,
second one is what all I understood is the static.
yes, the node, the zone are static, but the members are changing. The vehicles can change from one zone to other zone and add on.
Zone you are fixed.
Yes, zone size is fixed.
Size.
Yes, only size is fixed. The number of vehicles are not fixed. They can change at runtime. Yes, sir.
What is the maximum?
Sir, maximum I have not fixed the maximum number of vehicles.
You must have got some number, no?
Yes, sir. Actually, I have selected 72 number of vehicles for my simulation
For a
purpose.
given zone or for the?
For total 72 number of 70 number of nodes I have selected for all the network, and the number of vehicles in zone.
Can we make zone dynamic anytime?
Dynamics,
Any
actually,
scenario where you think the zone should be?
actually dynamically I didn't try it. I can try it for, I want to do for that purpose also. I will go for it because I searched somewhere in the net that we can use the mobility pattern and.
Any other software other than NS2 is there?
So yes, OpenNet is there, and OpenNet plus is there, Sumo is there. There are many other software available for basically these are the software for designing the mobility scenarios.
Is it possible to compare any of your data with the literature?
Sir, I can compare this with the data,
Then you have to
but
bring it to
for the platform. Actually, I tried this, but initially I was in a dilemma, so I selected. In my case, I have selected 250 cross 250 2500 meter cross 2500 meters area, and in that paper the area was 2500 cross 1500.
What
That's one.
she did is, initially she tried to compare her results with the literature review paper, the one paper which she has referred. I said, when the environment is not same, when nothing is same, so you cannot compare. So you compare with your own results.
That's what I said.
Because
No, I wanted to say
so she
you
had done
cannot
that
compare this.
initially. She had done that initially, but then I asked her not
You can
to
compare apple and apple, you can compare orange.
Yes sir, that's why ma'am actually suggested me that the parameter, the area, simulation area was also not the same.